Thank you for joining today's webinar. It will begin shortly.
Good afternoon, welcome. I'm Joan Engebretson. I'm executive editor with Telecompetitor, and we're here today to talk about using GIS to improve your business with data and analytics. I know everyone's busy these days, so we appreciate you taking time out of your schedule to join us for the webinar. The webinar is being recorded and will be available for viewing within the next day or so. Next slide, please. So before we begin today's webinar, I'd like to recognize and thank our exclusive sponsor, Finley Engineering. Finley is a full-service engineering consultancy serving both the broadband and electric utilities industries. They have 9 offices nationwide, and since 1953, they have been implementing projects coast to coast. You can find more information on their website at www.finleyusa.com. So our goals for today are to learn about sources of geographical data that can help you with your planning, particularly your network planning, how GIS data can be managed to create detailed color-coded maps, and advantages that can be gained from leveraging GIS content in your broadband deployment. At the conclusion of this discussion, we will be taking questions from the audience, but you don't have to wait until the end to enter your question. You can use the Q&A tool at the bottom of the screen and enter the question whenever they occur to you, although we will address them at the end. Next. So we're lucky to have with us today a great industry thought leader in Chris Konechne, who is a project engineer with Finley. Chris is an experienced professional engineer providing engineering and consulting services to clients on fiber buildouts and other telecommunications projects. Chris's experience extends across multiple markets and includes a wide range of engineering applications. His ability to bring this multifaceted knowledge and apply his skills to client projects opens up additional perspective and problem solving. Chris, take it away.
Thank you, Joan. Appreciate the opportunity and everybody's time here today. Today's topic is really on GIS and how the underlying data and the analytics can really improve not just your network planning and deployment, but really can reach into all aspects of your business. To kind of have a little fun with the topic today, we kind of threw the term Moneyball at it. so for those of you that are familiar with the movie and kind of the whole Billy Bean story, Billy Bean was the general manager for, having a little trouble here advancing the slides. There we go. So Billy Bean was the general manager for the Oakland Athletics. He came on board at a time when the franchise had a lot of success, and then became the team was sold and put under new management and ownership. And during that time, they slashed payroll, and he kind of had to come in and do a lot with nothing, or a lot less than they had in the past. So I think for a lot of broadband service providers across the country, there's a lot of parallels that can be drawn there. You know, when you think about, you know, the Athletics being kind of a small market team going up against the Yankees, one great quote from that movie is, "We can't do the same thing the Yankees do, given the economics, we'll lose." And I think that holds for a lot of people here. You know, everyone would love to go out and overbuild these giant cities and get thousands and thousands of subscribers, but you know, due to a lot of factors that might be somewhat out of your control, funding, where your network's geographically located, all those factors, you've got to find a way to do more with less, and GIS and some of these analytical tools can kind of help you find those undervalued and diamond in the rough type projects. So with that, I think we'll kind of start off with a poll here. So just to kind of get a feel for the audience and what our level of familiarity is, if you could answer, are you using GIS in your business now? And if so, kind of how? So yes, we're using it for strategic planning or funding. Yes, we're using it for construction, operations, like a mapping system, or for marketing and sales, or no, we're not using that at all. And we'll just give everyone here about a minute to answer that. Okay, so it looks like we do have, you know, the majority of the people here using GIS platforms, which is great. And this is kind of what we would expect, that a lot of people are using these systems for planning or funding mechanisms and even construction. But where it kind of starts to fall off maybe is some of the operations and marketing and sales. And I think we can kind of try to highlight some of those use cases moving forward here. So to start off, for maybe some of those people that aren't familiar with what GIS is, GIS stands for Graphic Information System. And each one of those words is really kind of key to what it is. It's a system that creates, manages, analyzes, and maps all types of data. And kind of a theme you'll hear me hit on throughout this process is it's kind of the marriage of what and where. So integrating location data, where things are, with descriptive information, and that's more of a what things are like there. You may have seen a GIS system very similar to this, and even if you aren't aware of it, you know, you're probably interacting with things like this and you don't even know it. This is Iowa's the broadband ability version 4 mapping data. So to kind of go back to that what and where, this is where there's no service, and the colors kind of correspond to what the service is like there. So in this instance, there was a 3-tiered approach, lacking access to, you know, 25.3, 50 or 100 megabit service. And then those were kind of scored accordingly in various funding mechanisms. States like Iowa and others are increasingly creating their own mapping systems to administer grants and funding opportunities like this. So it's more important every day to be able to understand these things and be able to capitalize on those opportunities. Iowa alone has offered $367 million of broadband expansion funding in the last less than 2 years. So, you know, for providers in markets like this, you know, if you haven't been up on this topic, you could have kind of missed the boat here in the last, you know, couple of years. To talk a little bit more about data and the types, data is everywhere, and it might come from, you know, some non-obvious sources. You know, we kind of joke that finding the data and getting good data is somewhat of an art in this field. Some types are spatial, so that's kind of back to that where thing. These are geographically referenced, you know, points, lines, polygons, grids, images, or terrain topo type features. These can represent in your network or your planning. It can represent, you know, eligible funding areas. It could represent addresses, poles, or if you have an existing network, it could be something like where your cable lies in the right of way. Attribute data, you know, attributes are our attributes are really what we're trying to visualize with some of this GIS data, and that's non-spatial characteristics. So kind of that what things are like, back to that. And often these are connected to spatial items or joined, if you're familiar with that term, so that you can visually represent them. So, you know, it might be you've got a spatial of where this cable lies, but then you've got an attribute that shows the count of that fiber cable, or the address of, or the actual physical postal address of an address point, height of a pole, things of that nature. And then the last is metadata. This kind of gets lost in the shuffle a lot of times, but it can be something that's very important and key to accurately utilizing GIS data sources. The metadata can contain information about the data set. So the scale, accuracy, projection coordinates, source, the vintage of the data. All of those are really important to understanding what the data source is and how to apply it appropriately. One of the big ones that we run into a lot is the projection coordinate system. So all this data that's referenced geographically, unfortunately, it's not all in the same coordinate plane system. So if you go back to your old, you know, high school algebra math classes, and you have the XY plane, that 0, 0 is not always in the same place. So we could be loading a data set for Minnesota and it ends up in the middle of the Pacific Ocean. That would be an obvious example of where we misprojected that data set. Next slide here. Another key, you know, benefit of GIS systems is when we talk about GIS, we're not just saying, you know, oh, like an Esri platform, although that's kind of the standard, you know, underlying engine of a lot of these different software programs. The fact is that once you understand this data and how to format it, it's really easy to pull data into or out of different platforms and move it in between them. And that's when kind of the light bulb will come on for a lot of people that are more heavily integrating this into their overall business. So obviously, you know, KMZs, shapefiles, georeference CAD files, global database, GDB files can all be put in there. But some of the less obvious things are, you know, there's ways to project PDFs onto these systems. There's ways to pull CSV data into here and join it to maybe geographically referenced data. There's a lot of times where we use like an Esri platform to convert files between different mapping systems. And last, you might be sitting on a gold mine of GIS data in your billing system today. We recently had some customers during the last 477 filings that they had kind of built their fiber networks or built their DSL networks, and they'd been putting the same 477 filing out year after year after year because they weren't really building or expanding their network. Well, now when the new filings are due and they had to convert to the new 2020 block codes, it could be wildly different. And with something like an Esri platform, we were able to pull all the Latin longs, or in some cases we had to geocode their addresses. So, basically we used a tool to assign a lat long to a normal postal address, and we were able to, really within an hour or two, most times, we could flip around those new filings and they were good to go. So just something to keep in mind when you are looking at integrating a GIS platform or software into your company, into your business. Make sure that it plays well with others and that you can pull data into or out of that system. To get into a little more of how you can use GIS in your network and business, I've kind of consolidated these into a few major categories. But the key thing is to start with good data, and then over time slowly add more and more data. The key to these platforms is the more data that you can feed into them, the more useful they're going to become down the line. Kind of the number one topic or number one response from the poll question was strategic planning. That is, in my role at Finley, doing strategic planning and grant writing, funding opportunities for our clients. This is the number one area that I use this tool in. And companies are increasingly using this to identify areas of opportunity. And really it has to do with the fact that these platforms can let us identify and estimate costs, much quicker than we used to be able to. This is a screenshot from a strategic planning effort that we're doing with one of our clients. This is such a complex ownership, issue that I don't know how we could manage it without this tool. Just for a little bit of background, there's 3 or 4 different phone companies involved with different but similar ownership groups, and there's also a rural electric co-op involved that is kind of helping out with this. And then to even further complicate things, their overall area encompasses 2 states, so a lot of moving parts to this. So when we started looking at how to grow their network out and evaluating opportunities, it was pretty daunting for them at first, because it was almost an insurmountable task. Is we could grow 50 miles in almost any direction and not run into any real stiff competition. So when we started looking at this, we looked at grant eligibility from both the state of Minnesota and Iowa's funding opportunities. We also looked at previous awards through those programs, as well as USDA, and we've added things like NTIA in the recent year or two here. We pulled in exchange boundaries from the FCC, and also we pulled in the 477 data for those counties, so we knew what we were up against in terms of other providers, be that fixed wireless, DSL, coax, what have you. Unfortunately, these are pretty rural counties, so they did not have address points, which we use to cost the network and identify demand, and then ultimately build the business model. We were able to work with the electric utility, and they fortunately had their electric meters GPS. So through some a little bit of filtering there, we were able to get a really good set of data points on where service could be taken. We pulled in the provider's existing infrastructure, so that told us things like key network cabinet locations, electronics locations, and also where they had spare fiber in their network. And then road lines, center lines, right-of-ways from both states, parcels. That was pretty key in filtering out those electric meters. If we had, you know, an agriculture farmland zoned parcel, odds are that was probably an irrigation well in the area, and we could discount that. And then we also looked at wetlands and field notes from our staff that we compiled in GIS. That allowed us to estimate more costly units like rock bores and wetland bores to make sure that we were accounting for those added costs. So you can kind of see how all these pieces and parts come together to build a very accurate model of the project. And all that allows us to do is really be much more efficient, put these things out in a much faster manner and be more accurate with them. This allows us to design project areas before the funding mechanisms come out. The timelines are getting shorter and shorter, and the amount of information that these programs asking for is seemingly kind of going in the wrong directions on both fronts. So having kind of that 5-10 year plan, or even a wish list of areas and what they would cost to build, it not only helps you, you know, identify the best targets for a given mechanism or funding program, but it allows you to be, you know, quote unquote, shovel ready before the NOFO or NOFA even comes out a lot of times. But that's not where the usefulness of this data ends. We'll get into it here in a couple slides, but it allows us to do some pre-planning that is critical, especially when you look at the labor and material shortages that there are in the market right now. So we can do things like preliminary contractor bids, fiber conduit pedestal orders, and it gets us a really good jump start on our staking sheets, to where before we'd send guys out there kind of with a blank map. Now we've got a pretty good idea of where all those cable routes and subscribers will be before we even start anything. One of the key times that this saved us was in Iowa's NOFA 3 here about 1.5 years ago. It's probably the only funding mechanism I've seen that was overfunded, and really a lot of providers shied away from this because of the tight timelines. In fact, only about $36 million of a $50 million total pot was applied and awarded. So, I mean, that right there tells you that this was a hard thing to pull off. For a little bit of reference there, the grant opened on July 20th without any advance notice. Nobody really knew more than a few days before that this was coming out. And the awards the grant applications were due about 2 weeks later. And about 2 weeks after that, a little more maybe, they put out the award notice. So, you know, in the span of right at a month, you went from 0 to 100, and then compound that with the build timeline, you only had about 11 months to build the project. So, and this was right at the beginning of you know, the whole COVID pandemic, and labor crews had no clue what they were going to be doing or how they were impacted. When this came out, we actually put a project on hold with a contractor so that we could, you know, save his crew availability to pull this off. Ultimately, we were successful with a couple of these, and really the only ones that even attempted it were those that we had been working on that long range feasibility plan with. You know, they had a 5-10 year plan to get all this fiber built, and then this was the perfect opportunity to execute on it. They had about 6 exchanges that they wanted to overbuild with fiber off of a fiber back DSL architecture. So within that, we used that existing plan that we had worked up to define an eligible area based off the state's mapping data. Once we had an area, we were able to cut those routes, reconfigure them slightly, and come up with a project budget. Iowa's grants are always based on, or have always been based on, census block inputs. So we're able to overlay the census blocks and pull those out instead of manually combing through about 400 census blocks and trying to count subscribers based on that. We also did a material order true up with the contractor. So I mentioned we held them off of another project. We were able to use those materials and then order the difference in the makeup between that. And we actually ended up, cable was so far out that we had to end up putting in conduit so that we could, kind of game ahead of that project and then pull fiber through in the winter months when it was a little bit colder and the ground was frozen. We also used it for closeout documentation, and now we're doing it with the 477 filings and the Connected Nation report. So that model kind of served us well in this particular instance. Kind of moving on down the line in the project life cycle, GIS in the field, we're seeing more and more GIS platforms out there, from railroad and county permits, and on and on. It's really becoming kind of the go-to standard. And there's a lot of reasons for it. If we have that high level design, it makes it real easy to slide into a GIS based, construction process. And increasingly, contractors are becoming more and more familiar with this. So it makes the sharing of data and updates a lot easier. You don't have to worry if some build crew is working off of Rev 1, 2, 3, 4, 5 plans. All that data, lives in an online database that can be downloaded. So you have to check on that. But the updates are much more easy to get out to the crews. Some other things is that we're reducing our field time. In the past, on a construction project, you probably have 65 to 75% field time, and the rest would be back office time. With these platforms, we're able to flip a lot of that time the other way around. So 65, 75% office time. That cuts our cost because we don't have, per diem trucks, burning fuel, assets out there in the field that are more costly. It's also just much more efficient. We used to have stakers that could do a mile or two a day on rural projects, and now they're averaging like 4, 5, and 6 miles a day because they're not out there drawing things. They're just verifying what's in there and making the changes as needed. It allows us to collect more data. If you think about something like a CAD or legacy platform that's not geo-referenced, all this stuff is somewhat referenced in the field, and then through some of the devices that you see on your screen here, they can go grab GPS waypoints for pedestals, for handholds, for the NID shells on the side of the house, and all that data can be useful down the line. The last thing is that it allows us to track progress in real time, which is huge. A lot of times we'll have weekly calls with our customers, and you used to have to the project manager would well, we're about this far, we're about that far, but reality, it was really difficult to sit there and tab all that up. So it was more of a gut feel, where now this process is automated. And we do a lot of that through custom dashboards. This is one that we're working on with our clients. And it's just like so crystal clear a lot of times what's going on with the project. And you can even start to identify, issues with construction, or maybe where a permit's holding you up. And it's really streamlined that communication flow between us and our clients. In this instance, you'll see kind of different serving areas laid out on a map. And then as the units are placed and the field inspectors mark them as ready for service, you'll see the symbology and the colors and the nomenclature change. And then all those fields on the left are customizable to what the customer want to see. Is if they want to see, mainline cable placement, drop placement, things of that nature, we can do all that. And then if you'll notice on the bottom too, you can have, it's not just a single pane of glass, there's layers to this thing. So for instance, this is a custom drop dashboard. So this really tells us, oh, hey, we've got 23 out of 42 drop units placed. How many ONTs added? It lets the customers know, and then we can run reports out of this, or we could run another dashboard that could be fed directly to marketing and sales. That would allow them to contact customers as the network gets built, as these individual subscribers come online. And really, if you think about getting an extra week, month, or even a couple of months of revenue off of larger builds, that's really just gravy or icing on top of the cake, because that's all stuff that if you kind of waited and weren't as efficient with your customer turn up, that it would just be all gone. Moving into operations, GIS for operations can be huge. This is kind of where we see some of this stuff fall off a little bit and less use, but it's gaining a lot of traction here recently. Increasingly, you're allowed to use GIS maps for locates. That can be huge, and it's not a matter of locating it down to like a 1 foot area, but it's getting people in the right area so you can go out there and mark and flag that cable if you have to. If you are working in a metropolitan area, we do have clients that are using sub-meter and sub-foot GPS locating because of the congestion issues. And in those scenarios, it's really been a lifesaver. You're already probably, if you're using GIS in your construction, you probably already have plant records and upgrades. Here again, we can build custom dashboards that will kind of show, maybe where your techs are, where today's request for service and turnups will be. So it can really bring a lot of efficiency there as well. And we kind of already talked about this a little bit, but the reporting with the 477s and the OSS BSS integration, if you are working in like billing systems that can integrate with GIS platforms, your techs can have access, or your customer service reps can have access to, hey, I don't have good service here. Well, that's maybe because you're only on a 10 or a 25 megabit plan, and maybe it's an opportunity to upsell. Resource optimization, again, if you can kind of track where those installs for the day are, you can kind of plan the most efficient route for those guys. And outage recovery, just whether it's your own crews or you're working with a preferred contractor to kind of do your cable repairs and fixes, it can just, there's no question about the area. Here's access to my system. It's at this lat and long. They dive in, see the cable, or maybe it's a pedestal that got backed over. It can just be that much easier. A little more into the operations here. This is a program called Maple Leaf. This is something that Finley's developed internally and is using to serve our clients. It's not the end all be all. There's a lot of mapping softwares out there that do similar things and do a great job. 3GIS, Vitruvi. I think there's probably about 8 or 9 software vendors out there that have really good GIS based mapping systems. But what they all kind of do is they'll visually lay out the network here so that you can kind of see, again, back to that what and where are all my cables, where are all my pedestals and vaults and subscribers. This is a little unique in that since we control it, it's, effectively infinitely customizable. So when you click on a handhole or a cable, these are all fields that we work with our customers to identify what's important to them that they see throughout the process. And then, we can pre-build a lot of this, and then this is where it goes from kind of a as state to as built, and then plant records essentially. Something that you won't see is that off in the right, there's a search bar. So oftentimes, especially if you have somebody new or unfamiliar with the area or your network, they don't know where, Cheryl Johnson's house is. But if you have that integration with your billing system, they can type that in the search bar. It'll kind of pre-populate. You can click on the one and it'll zoom you right to that house. And then you could see, okay, well, here's her billing package, or a lot of times we're putting in the light loss from when that fiber was put in. So they can look at this data and say, well, I should expect about this light level from the OLT platform. And maybe that's a little low. So maybe we got to look for a cut or a kink or something like that. Also, the backgrounds are customizable. So this is kind of just in a street mode right now, but we're able to overlay like a Google or satellite imagery, or even custom LiDAR. Again, back to the metro areas where things are really fluid and changing. A lot of our clients are opting for custom LiDAR data that will kind of really precisely marry the cables that we have drawn on there versus where things are and what they look like in the field. And that's super helpful in, downtown Minneapolis, downtown Dallas, areas like that we've worked in the past. Kind of the next bucket, and this was one of the lowest responses, is marketing and sales. And this is one of those areas where if your whole company and organization kind of embraces a GIS or data analytics type of approach, you'll get sales and marketing people that once the light turns on, like you almost got to shoo them away, because they get really excited because it allows them to be more efficient. So right now, some of the things that we're doing is pre-sales and marketing for new projects, or even doing market surveys and pre-signups before we even apply for grant funding. If we have two potential project areas and we send out surveys to both of them and we get a much more positive response on one area, that might be enough to push the company to build that area first. This is huge for CSRs, again, with that integration with the billing. It's kind of a single pane of glass that they can use to upsell customers, improve the customer experience. They might be able to tell, hey, your problem might be a Wi-Fi issue. Would you consider going to a managed Wi-Fi product, and that sort of thing. We'll get to this in the next slide, but for fixed wireless, I know we've talked a lot about fiber today, but for fixed wireless providers, this is amazing tool to pre-qualify customers and cut down on your install times there. Identifying high value customers. So if we're evaluating two project areas and maybe one of them has high value customers that we can identify through public data sources, that might be a cell tower from the FCC's tower registration database. It might be a school, it might be a library or a hospital. All those high value, high targeted customers can kind of push you to do one project over another. And then quickly responding to pricing requests. If you've got all your plant records in there, I can snap a line in the rural areas, have a pretty accurate footage of what that cable mileage might be, and boom, I can give you an estimate almost on the spot. Another area that's been really exciting for a lot of our clients is gaining more customers within your existing footprint. So what people are doing there is using that billing data and truing it up against something like a county address data point set. And you're able to filter those sets against each other to figure out what customers you don't have and market directly to them. Or maybe you would want to combine that and target your existing customers with like a friends and family type sign up, get a free month of service if you reference another customer. So all those types of things can allow you to be a little more targeted and precise with your marketing efforts. So back to that fixed wireless analogy, this is a client that we worked for, and this is kind of another like data layer minefield, and we had to pull a lot of sources together to pull this off. But what you're looking at here is a heat map or a propagation study that basically models the fixed wireless coverage and signal strength at various areas. And that has to all do with the height and power of the radios and kind of the terrain that it operates in. This particular tower was right on the border of 3 counties. So we had to pull 3 different county address data sets in. The provider we were building it for, it was inside of their exchange, but it would also serve customers outside of their exchange. So we could use that to fine-tune numbers for ACAM or hub reporting, as also kind of custom tweak the projected take rates. Maybe they would only expect 20% of the customers in their DSL to convert to fixed wireless, and none of the fiber customers would convert, so we could cut those areas out. This propagation model is run at a 10-mile radius. That's maybe a little ambitious for this customer density and area, so we were able to trim everything outside of 7 miles. It really just kind of helped us dial in on all those numbers. And then this file lives with the customer, and I wish I could kind of zoom in on it here, but it's accurate to about a 3 square meter area. So the CSRs, when they get a call for service on a fixed wireless location, they type in the address, it takes them to that address point. They can see, yes, you can get service. Here's what packages might be available, or no, you can't get service at all. And then once they do send somebody out there to hook service up, it greatly provides a lot of efficiency there, because they're not hunting around for, well, do I mount it on this roof or this part of the roof, or do I do it on an outbuilding? They can look at that heat map and say, here's where my best signal is, and here's where the easiest install would be. It allowed them to go from 1 to 2 customer installs a day to 4 and 5 customer installs a day. So, that's huge when you think about how much revenue and how much more efficient those people are being out in the field. The last thing I'll hit on here, and I've kind of been purposely avoiding it just to kind of close out with it here, is the new FCC's federal broadband data collection. This represents a pretty big shift in how the FCC will map and report data across the country. And it's also likely going to be, the bedrock data set that the BEAD grants and some of the $65 billion in funding are going to be based on here next year. A few highlights of this is that number one, instead of that list of census blocks that you were all maybe used to, you're going to have to submit custom polygons or shapefiles or CSV lists of all your existing service areas. So the FCC is trying to provide, in their words, location specific access. And that'll be areas that are available for service within 10 days. And if you're a wireless provider, I would highly recommend that you get ahead of this process now, because they're basically going to require you to list every antenna location, make, model, channel. There's just a laundry list of requirements for fixed wireless providers. And it can be a pretty daunting task if you're a bigger provider with a large service area. That data will be as of data June 30th. So, how you're deployed as of June 30th, and will be due September 1. So that's definitely something to keep an eye on. And it just, again, further integration of GIS systems into our world. So with that, I'll turn it back to Joan.
Thank you, Chris. That was really interesting. I really learned a lot on that. It's time now to take questions. As a reminder, you can use the Q&A button at the bottom of your screen to ask a question, and then you just type it in. I do have some queued up already.
Okay.
One is, do you prefer the Polygon or CSV method on broadband data collection?
My answer to that is probably going to depend a lot on what type of data you have already. If you're kind of limited on the data and the resources that you can expend on this, it might be easier to do the CSV method. But for a lot of reasons, I think the Polygon probably makes more sense for most people, because really what you're looking at is where can you serve, not where do you serve. So if you're putting out a list of where you provide service, that only tells the FCC and the world, like, here's where I do serve. And when you look at something like a fixed wireless network, you probably have a much larger potential for service than the actual number of live customers that you have on there. But even fiber networks, especially where you're competing with a cable company, you might have ubiquitous coverage through an entire town, but maybe you're only 60% penetration because you're going up against an incumbent cable company, and it's just taking you a while to get those customers. That could lead to some spotty reporting areas. We'll see and know more. People are just starting to get access to the fabric and data right now. So I think that'll become a lot more clear for individuals as we get further into the process.
Thank you. There is also a question. What other publicly available GIS broadband data and data sources do you recommend in addition to the FCC data?
Sure. It probably depends a lot on what funding mechanism or what your purpose, what your goal is to do with the data. States are increasingly putting out their own maps. I think Minnesota's been publishing their own GIS maps for about 7 years now. So state data is number one. Number two is probably county data. A lot of counties have really good data for E911 parcels, or it might be a city too. And then, the third source might be get friendly with your local utility providers, especially if they're a municipal co-op type of entity. They might not be so ready to give that data up front, but once you explain to them what you're after and how you're trying to solve a problem with their city or co-op membership, you'll often get a different answer.
As a reminder, if you'd like to ask a question, please use the Q&A button at the bottom of the screen. You can click on that and then just type in your question. I have a really basic question. Are these GIS systems cloud-based?
Many of them are. If they're not cloud-based, they live on a server somewhere. The cloud is great because it allows you to have that data, kind of geographically redundant and easier and quicker to access everywhere. But that being said, most of these tools have the option to download data onto a tablet or a laptop and work offline, because if you obviously are building broadband in areas that don't have service, your ability to connect to those cloud sources might be somewhat limited.
Right. And then how difficult is it to learn to use GIS systems? Are there certain applications that a service provider can do for themselves, and others that they might need to have someone that specializes in it, do the work for them? Sure.
And it probably comes down to scale and how much resources you can throw at it. At Finley, we probably have about 40 staff right now that can run GIS platforms or specifically Esri licenses out there. That number is growing literally by the day. And we have a lot of very well-trained and expert people here. But if you're a smaller provider with limited resources, there's some kind of telecom specific GIS overlay type software packages that they're kind of frankly an easy button. And there's nothing wrong with those. They're great, and they kind of give you everything you need and nothing that you don't. So I think it just matters, what your appetite to get into this is. It might be something to start easy. Google Earth and map it right. And there's some great free, basic stuff out there that can really kind of, get your feet wet.
Again, if people would like to ask any questions, just use the Q&A button at the bottom of your screen, click on it and type in your question. I have one or two more myself. When states create their own mapping system, do they do a data collection from service providers, or how do they determine where broadband is available at various speeds?
Yep. Most of the state data collection efforts, again, they are state collected and from the providers themselves. So sometimes you got to kind of take that with a grain of salt. Just like the federal mapping, there's been a few bad actors out there that kind of ruin it. Thankfully, most of the states have an open challenge period. So this is a case where you want to make sure that not only is your data correct, but those areas that you're eyeing up for expansion, that there's not somebody overstating claims there that might block you out of a funding opportunity.
Okay, I have another question from the audience. They are saying we often get parcel shaped files from our county without an actual address point layer. Any recommendations for converting parcels into actual address points without manually plotting each one?
Sure. So sometimes there'll be like a tax ID address on there. And what you can do is go through all those parcels and pull all the tax ID, the mailing addresses out of there, and then geocode those. So I'm probably speaking Greek to some of the people that are maybe, GIS 101, but there's ways, and nothing's perfect in that situation. You're going to have to do some sort of batch process like I described and get close. And then you're probably just going to have to hand verify some of those. The other option would be to look if there's some sort of zoning code on there. There might be like a residential or business code on there that you can force Esri or some platforms to push a point to that.
Okay. Another audience member has asked a question that I'm interested in hearing the answer to as well. How do you work around or adjust for bad data from the FCC Form 477? I think everyone's aware of the issues with that data. It tends to overstate broadband availability because it considers the whole census block to have service, even if only one location has service. How do you work around that issue?
Sure. That's a question that we get a lot. Thankfully, states and the FCC even are moving away from census block level reporting. Oftentimes your hands are kind of just tied when that's how the law or the funding is written. If that's not the case and you just think somebody's overstating their service, our recommendation's always been to do good speed test and get addresses and points with that. So that gives you cold hard data, whether it's to USDA or the states or whoever it is, to refute that. A well-conducted speed survey test with address points of those test locations is probably your best bet to refute that data. And then make sure you're challenging it at both the state and the federal level as well.
Would that approach also be good if, let's say, you wanted to challenge someone's award in all these various funding programs? Maybe someone got funding for an area where you believe there's service, or is that the approach you'd recommend there as well?
Yep. So challenges can kind of come from the challenger or the challengee or the builder or the person being overbuilt. Or sometimes you have to challenge the challenge of another provider. So in one case, we had applied for a grant, and we got challenged by someone that showed us their coverage territory, and I won't say where it is, but it was a grossly overstated estimation of the capabilities of a fixed wireless network. And we went direct to the manufacturer and showed them all the data and said, is this even feasible? And they said, not at that scale for, you know, ubiquitous 100% coverage. And then we backed that up. Prior to applying for that grant, there was about 1,500 locations in that project area, and we solicited about 300 bills, and there was only less than 1% from this fixed wireless provider. So like, that was a good chunk of evidence to say, like, you might be able to offer service, but you're not giving the broad bulk of these people what they need.
And was that challenge successful?
Yes, that program, that funding ultimately went through. Yes.
Mm-hmm. I have another audience question. Is there any nationwide address data that companies would sell? Is there a company that you are aware of?
There are, but it's not perfect. They don't have every county, every state. Often that data is quite expensive. It's much more, you know, you're talking on the order of 25 to 50 cents a rooftop. So that is just kind of a non-starter. I'm hopeful with the direction that the FCC is moving and some of this quote unquote broadband fabric they're creating through the BDC, that data will become public and providers will have better access to that data. But right now, you know, really it's best to just work that at a local level. If you're lucky to live in, you know, I think New Mexico, Wisconsin, and a few others, the state actually publishes all that data. So if you're there, you know, good for you, but the rest of us are still kind of struggling with that at some times.
We are just about out of time. I'm going to ask for one quick, if anyone has any more questions, type them in right away using the Q&A button. This has been a really interesting presentation today. I don't see anything more coming in. So it is almost the top of the hour. So I think it's about time to wrap it up. Chris, I really appreciate your time today. This was a fabulous discussion. I think people learned a lot. And the question and answer session was really helpful too, I think. So thanks again.
Thanks, everyone. Appreciate your time.
Thanks to all the participants for joining us today. Thank you.